Okay, new chapter. Chapter 9 talks about rational functions. And when you guys were in grade 11, we dealt very briefly with this. Okay, they were the kind of graphs that, I don't know if you remember, but they kind of look like this. They kind of look like that, and if you had a quadratic, sometimes it looked like this. Do you guys ever remember those?
Yep.
Okay. So those are the type of functions that you'll be dealing with today, just with a little more detail, actually quite a bit more detail, because you are smarter and better and awesomer and can comprehend things of a higher order of thinking. Okay? Rational functions are used in a lot of different circumstances. They can be really nice for when you want to scale up or scale down a modeled problem. Okay? If you realize that your function is maybe too big or too intense for what you're trying to model, you can use a rational function to vary your values, either scaling them up or scaling them down, to make them fit your data better. Other areas where you see rational functions are when two things are inversely proportional to one another. That's something that I've briefly mentioned in physics before, but I'll talk about what that means again today. So in this chapter, you'll be studying these types of functions, rational functions, and some of the unique characteristics that they have. And by the end of today, I'll show you an example of how cell phone companies use the concept of rational functions to charge you the most amount of money. Well, not charge you the most amount of money that they can, but it's a model that shows how cell phone companies plan to make money off of you. Right? I'll show you some of the marketing techniques that they use and how rational functions are related to that. So first of all, what is a rational function? In general, it's basically this. Okay, it's a function where you have two polynomials, p of x and q of x, divided by one another, and of course q of x can't be 0 because you can't divide by 0.
Q of x is always on the denominator.
Yeah, like just p of x means there's a polynomial up top, and q of x means there's a polynomial down below. Okay. So just some examples. If you had something like f of x equals 3x plus 10 over x minus 1, right? P of x would be 3x plus 10, q of x would be x minus 1. Okay, another example could be something like 1 over x squared, even. So yeah, you'll see lots of examples today, but that's basically what it is. You have two polynomials divided by one another, and they have some unique characteristics. Okay, you've actually seen several rational functions up until this point, both in Science 10 and Physics 11. You guys know the equation for speed, v equals d over t. Okay, that's a very famous equation that most high school students know. That's a rational function, right? You have the polynomial just d divided by the polynomial t, where t can't equal 0. There's the relationship between the frequency and period of an object in simple harmonic motion. So if you remember, like a point spinning on a tire, or a pendulum bobbing back and forth, or a spring, a mass on a spring bouncing up and down, okay, a wave, okay, those are all simple harmonic motion examples. And the frequency of that motion and its relationship to the period can be shown using this formula and this formula. And in these formulas, f and t are inversely proportional to one another. And this is more of a physics concept. But basically all it means is the larger one thing gets, the smaller the other thing becomes. So the larger the period gets, the smaller the frequency, or the larger the frequency, the smaller the period. Okay, that's what inversely proportional means. Newton's third law of gravitation, okay, is another example of a rational function, okay, where you guys have seen this before, right? Measuring the force between two masses that are a distance apart, right? The idea is if you and that thing were the only thing in the universe, you would be attracted to each other, right? And you would eventually collide in a very anticlimactic collision, right? If you and a picture of Justin Bieber were the only thing in the universe, you would be attracted to each other, unfortunately.
More like this.
Okay. Yeah, and you would collide, I think, pretty slowly. It wouldn't be very intense. Kepler's third law I don't know if you remember this one from Physics 11. This helped you determine how long it would take for something to rotate around another planetary body, right? So we dealt with a lot of cube roots and square roots, and we dealt with that. And then the piecewise function for the Doppler effect is also an example of a rational function. You'll notice that the fractions appear there as well, right? And you guys remember what the Doppler effect is?
Like a race car going by you.
Yeah, like, right? And it also changed the wavelength of light, right? There was that, I don't know if you remember, but this is kind of stuck in my mind. That one problem where the guy was like speeding to get through a light before it turned.
Well,
What was
no,
it?
appeared green.
Yeah, it appeared green, but it was actually red because of the wavelength that Doppler shifted.
Yeah, it's like
But he'd have to be going like 70% the speed of light in order for that to happen. So so if the cop knew physics, then yeah, he wouldn't actually get away with it, even though it legitimately looked green. But these are just some examples of rational functions that you have dealt with. Okay, just to show you that they've been creeping there on the sidelines without you maybe not realizing it.